Fourth grade lesson 6.4 is common denominators. These are real important for us to be able to create because it's very, very difficult to compare two different fractions with each other if they're not cut up the same way. So finding the common denominator of those fractions will help show a comparison of two things that are cut up in the same way. Also, it's really important for when you need to add or subtract your fractions later, because again, you need to have them cut in the same size pieces, and that's what the common denominator will do. Let's start off by looking at the essential question. How can you write a pair of fractions as fractions with a common denominator? Same number as their denominator, as their bottom number. Let's look at the unlock the problem. Martin has two rectangles, that are the same size. One rectangle is cut into 1/2 size parts, two as our denominator, right? The other rectangle, which is the same size, is cut into 1/3 size parts, 3 as the denominator. He wants to cut the rectangles so they have the same size parts. How can he cut each rectangle? A common denominator is a common multiple of the denominators of two or more fractions. Fractions with common denominators represent wholes cut into the same number of parts. So let me break this down. They used a lot of math vocab. I want to make sure you understand. Common meaning the same. Denominator is that bottom number of the fraction. So the same denominator, the same bottom number, is going to come from the common multiple, the same multiple that they match on. Remember the multiples where if you count by a number, those are all of its multiples. So multiples of 2 are 2, 4, 6, 8, and on. And multiples of 3 for this denominator are 3, 6, 9, 12, and on, right? Their common matching denominator is 6. Remember doing lowest common denominator or lowest common multiple? That's the same thing. It's just now it's for use. That's the tool we're using for our denominators. Okay. So we're going to start, by the way, the common denominator of these two fractions, 1/2 and 1/3, is going to be 6. But let's have them take us through so your brain knows why is it 6. So we wanted to find the common denominator of 1/2 and 1/3. Model the rectangle cut with 1/2 size parts. Fold one sheet of paper in half and draw a line down the fold. So you have it here for you already, but if you want that on paper because you're going to want to be folding things up, go ahead and get a piece of paper and do that. Then model the rectangle cut into 1/3 parts. Fold the other sheet of paper into thirds and draw lines on the fold. So do another piece of paper like that. Fold each sheet of paper so that both sheets have the same number of parts. Draw lines on those folds. How many equal parts does each sheet of paper have? So if you compare these two, the lines that this one is missing that this one has is going to be right here. So I'm going to draw those. If you folded them, you already have them all drawn. And on this one, the fold that this one has that this one doesn't is this lengthwise one, so I'm going to draw that on there. And so now they're folded up in the same ways. In fact, I'll put those already dotted folds, I'll put that on there. And so now how many pieces are they both split into now that they match? They're split into 6 equal pieces. So each rectangle could be cut into 6 parts. Okay, now that we know what's happening, let's see what we do to get it to happen. They want us to write 4/5 and 1/2 as a pair of fractions with common denominators. You can use common multiples when you count by each number to find a common denominator. List multiples of each denominator. A common multiple can be used as a common denominator. So for 5, for this denominator, we're going to count by 5. 5, 10, 15, 20, 25, 30. And then we will count by 2 for this denominator. So 2, 4, 6, 8, 10, 12. Then we're going to take a look and find out which ones they have in common. What's the lowest one? Really, ideally, we want to keep it the lowest one that they have in common, the LCM, the lowest common multiple. Also, you'll hear LCD, lowest common denominator, the lowest one they have in common. They have, if I look through, I don't see a 6 here. I don't see an 8 over here. 10 is the first one I see that matches. So 10 is going to be my lowest common multiple, or also my lowest common denominator. So my goal, now that I know where they're going to match at, my goal is to change the denominator on both of those fractions to a 10. Remember this error alert on your book, it's cut off on my picture, but on your books, remember that when you multiply the denominator by a factor, you must multiply the numerator by the same factor to write an equivalent fraction. We are using our knowledge of equivalent fractions to force this denominator to 10, because we can also force this denominator to 10 too. And we have to force them both to 10 in order for them to have a common denominator so that we can compare them or add them later or subtract them later. So we need a common denominator, and 10 is the one that they're going to match on. That's the first one that they do. So I know in equivalent fractions that whatever I multiply my denominator by, I have to also multiply my numerator by. So let's do our little magic for equivalent fractions. This is a 5 and I want it to be a 10. 5 times what number will get me 10? 5 times 2 will get me 10. And whatever I do, let's do a different color for that. Whatever I do to the denominator, I must do to the numerator as well. I must do the same thing to his best friend. 4 times 2, 8. So this is the equivalent fraction of this, but now the denominator is where I need it to be. So we're using that understanding of equivalent fractions to our advantage. Now I have 1/2, and I know that they're going to match at 10. That's what I found out here. So I need to force this fraction into an equivalent fraction with a denominator of 10. 2 times what number will give me 10? 2 times 5 will give me 10. And if I multiply the denominator by 5 and I want to keep it equivalent, I must multiply the numerator by 5. And there's 5/10. So we can write 4/5 and 1/2 as 8/10 and 5/10. And now they are equivalent to their original version. They're still the same amount. They're just cut differently. But now they're cut differently in such a way that I can tell which one's larger than the other, right? Because in this case, getting 4 pieces, it's hard to tell what does that compare to with this one piece, because this is cut into 5 smaller pieces and this is cut into 2 big pieces. So I needed them cut the same way. Then I would know which one's bigger, which one's smaller, that sort of thing. I could add them together if I needed to. So I had to force the same common denominator. Okay, so they ask us, are 4/5 and 1/2, 4/5 and 1/2 equivalent? Are they the same amount? Well, take a look. If I cut this 4/5 differently into 10 pieces and I cut the 1/2 into 10 pieces, on the 4/5 I get 8 of those 10 pieces, and on the 5 and the 1/2 I only get 5 of those 10 pieces, and that is not the same amount of pizza. So are they equal or equivalent? No. 8/10, also known as 4/5, is more. It's more than 5/10, right? 8/10 is more than 5/10. So 4/5 is more than 1/2. So they're not equivalent. Describe another way you could tell whether 4/5 and 1/2 are equivalent. Well, we could use the skill we had in our previous lesson where we had 4/5, let's say, and 1/2. I'm going to write it this way just because I'm going to go across this way. Is it equal or not equal? Is it equivalent or not equivalent? Well, I'll start here because 1 times anything gives me what it is over here. So 1 times 4 is 4. Is 2 times 4 5? No, it is not. No, it is not. So that's another way I could do that. So if they want that explanation, times, that's a terrible color. It's just not coming out. Okay, let's try this. 1/2 times 4 equals 4 times 4 does not equal 5. that is my way of explaining it, not with words, but with numbers, but that works too. Let's look at the share and show. Number one, they want us to find the common denominator for 1/3 and 1/12. They gave us pictures, 1 out of 3 and 1 out of 12. By dividing each whole number in the same number of equal parts. Use the model to help. And what you're going to find is, especially if your multiplication facts are really solid, you're going to find that you'll start finding common denominators very quickly, common multiples very quickly, with practice. But if not, that's okay too. But you'll want to count by, I did not mean to mark on that, you'll want to count by do the multiples of these numbers to find out where they match. So take the denominator 3 and count by 3s. Take the denominator 12 and count by 12s until you find a match. So we'll start with 3, 3, 6, 9, 12, 15, and count by 12s, 12, and stop. Winna winna, chicken dinner. I found the match right away. You might have seen it visually if we had just cut this to look like that. Then 12 is a common denominator. So our common denominator will be 12. I'm going to take this problem a step further just for the practice sake of it. I don't have to change the denominator of this one to 12 because it's already 12, right? So if I wanted 1/3 to have the same denominator as 12, a common denominator, I would need to do something to 3 to make it become 12. Multiply 3 times something to get it to become 12. And of course, 3 times 4 equals 12. And I must do the same to his best friend, the numerator. 1 times 4 is 4. So the common denominator of 1/3 is 4 twelfths. And of course, visually there, that is 2 4 twelfths. So this number is 1/3, the equivalent fraction of 1/3, only it's with the common denominator to this number. Okay, and then numbers 2 through 5 want us to write the pair of fractions as a pair of fractions with a common denominator. So I first need to find which denominator, which number they will both match at. And once I find that, that's what I will change both denominators to. So I'm going to look at this denominator, 2, and this one, 4. And you might right away start seeing, like, I can make that 2 become a 4, right? You're going to start seeing that. But until then, do these steps. I'm going to count by 2, 2, 4, 6. And I'm going to count by 4, and winna winna, chicken dinner, that's where they match. I didn't have to count by 4 very far, did I? And so 1/4 is already a fraction with a denominator of 4, and all I need to do now is change 1/2 so that it is a fraction with a denominator of 4. What do I multiply 2 by to get it to become 4? I multiply that by 2. And what do I do to the numerator? The same thing. Best friend gets the same treatment. 1 times 2 is 2. And here are my two fractions with a common denominator. Let's look at the next one. You might be thinking, oh, I think I'm kind of getting this. All right, 3/4 and 5/8. I want these fractions to have a common denominator so I could tell which one's bigger or which one's smaller. So let's count by 4 and let's count by 8. Or if you already noticed, I know how to make 4 become an 8, right? Let's count by 4. 4, 8, 12, ... Let's count by 8, 8, 16. But why did I go to 16? I didn't need to because winna chicken dinner. And already, so my LCD, my lowest common denominator, or my common denominator is going to be an 8. And looky there, that guy already is an 8. I don't have to do anything to him to change him. He can stay the same. I like him just the way he is. But this guy I'm going to change into an equivalent fraction with a denominator of 8. So 4 times what number gives me 8? 4 times 2 gives me 8. And if I do a times 2 times the denominator, I must do a times 2 times his best friend, the numerator. And there we are with the equivalent fraction of 3/4, but the denominator I need. And look what happens, and this is what's coming up in these next couple of lessons, is to compare which one's bigger now. I couldn't compare which one was bigger here because they were cut differently, but now they're cut up the same way. And 6 of those 8 is more than 5 of those 8. You see where this is going? So this is why this is an important skill. Okay, this one takes it up a little bit of a notch, but you'll see it's fine. For those of you who were noticing an easy common denominator, here you may not see it right away, not yet, or maybe you do, I don't know. Because right away you're thinking, well, 3 times nothing gives me 4, so I don't even know. What am I going to do? Count by 3, and then count by 4, and find out where they match. So 3, 6, 9, 12. I don't know if I'll need to continue. I will if I need to. Let's go down to the 4 and count by 4s. 4, 8, 12. Ooh, there it is. Winna winna chicken dinner. I found their lowest matching one, their common multiple. And so I need both of them to have a denominator of 12. And right now, neither of them do, but that's okay. I know how to control. I'm the puppet master of these fractions. I know how to control them. I'm changing 1/3 into a fraction with a denominator of 12, and I'm changing 1/4 into a fraction with a denominator of 12. What do I multiply 3 by in order to get it to become a 12? I multiply it by 4. 3 times 4 is 12. And I do the same to his best friend. And then how about over here? 4 times what gives me 12? 4 times 3 gives me 12. And I do the same to his best friend, the numerator. And so now 4 twelfths and 3 twelfths are easy to compare to one another because they're cut up the same way. This amount is more than this amount. So this amount is more than that amount. All right, ramping it up a notch again. We have 4 twelfths and 5 eighths, and I need their denominators to be the same. It's hard to tell in my brain if 4 twelfths is more or less than 5 eighths. So, or if I had to add them together, I can't add them together until I cut them up the same. So we need to find their common denominator. So I will count by 12, and then I will count by 8, and then I'll find out where they match. So we've got 12. What's next on 12? 24, 36. I'll wait and to go back to that if I need to. Let's count by 8, 8, 16, 24. Oh, there we go. Winna winna chicken dinner. There it is. So I need both of these fractions to have a denominator of 24. So I'll go do my puppet skills and have full control of these numbers. I'm going to change 4 twelfths to a equivalent fraction with a denominator of 24. And I'm going to change 5 eighths to, that's an 8, to an equivalent fraction with a denominator of 24. And I know each of those will become 24 because that's where they matched. I counted by those numbers. That's why I do that. 12 times 2 is what gives me 24. So if I multiply the denominator by 2, must multiply the numerator by 2, his best friend. And there is the equivalent fraction with the denominator 24. Then over here, 8 times 3 is what gives me 24. Again, knowing my multiplication facts makes that so much faster. Do the same to the best friend. 5 times 3 is 15. And so 8 24ths and 15 24ths are the two equivalent fractions to these two. But now they have the same denominator, so they're much easier to compare. 15 out of 24 is more than 8 out of 24, so this is a bigger fraction because that's its equivalent. And that's what this lesson is all about. I hope you'll be able to handle this one on Think Central, but if not, we can go over it again some more.